You know that heart-stopping moment in live production?
Yeah.
The one where the main screen flickers for just a fraction of a second, and everyone in the control room just holds their breath.
Oh, yeah, the dreaded dropout. I mean, it's the absolute nightmare scenario for any broadcast engineer.
Right. And we spend so much energy obsessing over the camera sensor or, the resolution of the LED wall, but the real failure point is usually that invisible plumbing in between. So today we're doing a deep dive into a piece of gear that exists entirely to stop that flicker from happening, the Kramer VM-2UX.
Yeah, officially it's called the 1.2 4K 12G SDI DA, which is a bit of a mouthful. But if you strip away the alphabet soup, this little box is basically an insurance policy against physics.
Well, let's get into that physics, because on paper it looks pretty simple. It's a 1.2 distribution amplifiers. You put one signal in, and you get two identical signals out. Why do we need a dedicated deep dive for what is essentially just a splitter?
Because calling it a splitter is actually pretty dangerous.
Oh, really?
Yeah. If you take a high bandwidth digital signal and just passively split it, like with a Y cable, you are effectively halving the signal strength.
Right.
You introduce reflection and noise,
Yeah.
and when you're dealing with the speeds that this device handles, that passive approach basically guarantees a black screen.
And speed is the key word here, right? The 12G in the name stands for 12 gigabits per second.
Which is massive. That's the bandwidth required for uncompressed 4K video at 60 frames per second, specifically with 4.2.2 color sampling.
That's a lot of data.
It is. Pushing that much data down a copper wire is really difficult. The copper fights you, it attenuates the signal.
Meaning the signal gets quieter the further it travels down the line.
Quieter, yes, but also much messier. We call it jitter.
Jitter. Got it.
The precise timing of those ones and zeros starts to drift. So by the time the signal travels, say, 50 or 60 meters, the receiving screen just can't tell a 1 from a 0 anymore.
And this is exactly where the VM2UX differentiates itself from a cheap splitter, right? The documentation highlights equalization and reclocking.
Yes. This is the critical insight for anyone setting up video infrastructure. Equalization fixes the volume. It boosts the frequencies that got lost in the cable.
Okay, but what about the reclocking?
Reclocking is the magic trick. This device actually strips the data down, recovers the original clock timing, and regenerates a brand new signal from scratch.
So it's not just shouting a distorted signal louder, it's completely rewriting the message.
Precisely. It completely eliminates the accumulated jitter. And that's why Kramer can claim a reach of 80 meters, which is about 260 feet, even at full 12G 4K speeds.
And looking at the specs, that distance jumps significantly if you drop the resolution.
Right, it's inversely proportional. If you're running a standard HD signal like 1.5 gigabits, this same box, using that same reclocking tech, can push that signal 200 meters.
Wow, 200 meters. And the device is smart enough to know the difference, right? It's auto-adapting.
Exactly.
I noticed you don't have to dip switch it to 4K mode or anything.
No, you don't. It detects the data rate, whether it's SD, HD, or 12G, and it just locks to it automatically. It also passes through all the ancillary data.
Like embedded audio?
Yep, embedded audio, metadata, timecode. It all survives the reconstruction process.
Let's pivot and talk about the physical build for a second. We're talking about the Pico Tools form factor. It's tiny.
It is, but the key feature for me isn't necessarily the size, it's the lack of moving parts. It's fanless.
Which really matters if you're hiding this thing in a dropped ceiling or a super quiet studio rack.
Or a hot broadcast truck where you definitely don't want another point of mechanical failure. And of course, it uses locking BNC connector.
Right, the absolute broadcast standard.
Exactly. You can't run a live event with HDMI cables that just slide out if someone sneezes. BNC twists and locks. It's the physical counterpart to that electronic reliability we just talked about.
So, to sum it up, we have a device that acts as a signal regenerator, fits in the palm of your hand, and runs cool without fans. It's essentially the backbone for modern 4K distribution.
It really is. It's the reason you can have a camera all the way out on the 50-yard line and a production truck out in the parking lot and still get a totally perfect image.
Absolutely. But here's the question I want to leave you with.
Yeah.
We've mastered 12G. We can push 4K 80 meters down a copper wire using this exact reclocking tech. But 8K is knocking on the door, and that requires 4 times the bandwidth.
Yeah, that's what we call the copper cliff.
Exactly. At what point does the physics of copper wire simply give up, no matter how good the reclocking is? As our appetite for resolution grows, the invisible infrastructure we talked about today is going to have to undergo a radical reinvention.
It's going to be a huge shift.
Something to chew on before your next production. Thanks for joining us for this deep dive.